Okay, so in this video here we're looking at finding the points of intersection. Okay, so and this is between this here, which is clearly a line, and this thing here, which is clearly a circle. So if I was to draw a picture of this, here's my circle, and maybe my line looks like that. And what we want to do is we want to find the points of intersection. I call them A and B. All right. So hopefully it's clear that this line here has a center of 0, 0, and the radius of this line is the square root of 10. Okay, so we want to find the points of intersection, so where this line cuts that circle. But you do the exact same if you had two lines. To find the points of intersection of two lines, you solve simultaneous equations, so you do the exact same thing here. So what we need to do now is we need to solve simultaneous equations between x plus y is equal to 4 and between x squared plus y squared is equal to 10. Okay, so I'm very quickly going to do this because we actually did this in 5th year. Okay, this is simultaneous equations, one linear, that's a line, and one non-linear because it's a circle. So this was already done in 5th year. So just to go over it very quickly, to do this, you need to get the linear one and you rearrange it to get x is equal to 4 minus y. Okay, and then you would put that in for x here. So to do this one here, it's x squared, but x is now 4 minus y squared plus y squared is equal to 10. If you multiply all of this out, you're going to get 16 minus 8y plus y squared plus another y squared is equal to 10. If you simplify this now, we're going to get a quadratic. We're going to get 2y squared, minus 8y plus 6 is equal to 0. If you want here, you can divide everything here by 2. So we're getting y squared minus 4y plus 3 is equal to 0. We solve this, y and y, we're obviously going minus 1, minus 3. So my two values of y are y is equal to 3 and y is equal to 1. So we know now that this line and this circle intersect at 2 points. See the way it makes sense that we get a quadratic? Because a quadratic always has two answers, and we need to have two answers because it cuts it twice. So we know that the y values now, so one of the y values is 3 and the other y value is 1. But we still need to find the x values. But we know that x is equal to 4 minus y. So it's x is equal to 4 minus, the first y value here is 3. So that's going to give me an x value of 1. So when the y value is 3, the x value is 1. And then our other y value is 1. So it'll be x is equal to 4 minus, but our other y value is 1. So that will be x is equal to 3. So our other value there is 3. So the 2 points where this line and this circle intersect are going to be 1, 3 and 3, 1. Okay, so here's the next question. So in this one here, we want to do the exact same. We want to find the points of intersection between this line here and this circle here. So once again, a diagram. So the circle there could look like that. And then this line, maybe it's coming up and looking like that. So we want to find the points of intersection there. We want to find the point A and we want to find the point B. Okay, so the procedure here is the exact same. We want to solve simultaneous equations between this and this one here. So again, I'm going to go through this very quickly because we did this in 5th year. So the linear one, you want to make sense here to get y on its own. So y is going to equal to 24 minus 5x. And then we're going to put that in for y here. So this here will turn into x squared plus y I now know is 24 minus 5x squared minus 4x minus 2 by y, and I know that y is still 24 minus 5x minus 8 is equal to 0. So now it's just a matter of squaring all this out. So that x squared is going to go there. Now I'm just going to very quickly square this out here. If we square this out here, you're going to get 576 minus 240x plus 25x squared minus this 4x. And then if you multiply 2 in here, you're going to get minus 48 plus 10x minus 8 is equal to 0. Okay, so that's just what you get when you multiply all this out. It is very messy, but again, we did do it in 5th year. To clean all this up then, you get a quadratic, which we would expect. The quadratic you're going to get is going to be 26x squared minus 234x plus 520 is equal to 0. You could try to solve that, but actually everything divides by 26, and you're going to get x squared minus 9x plus 20 is equal to 0. So now we just have a quadratic, x there, and it's going to be minus 4 and minus 5. So there are two values of our x's. X is equal to 4 and x is equal to 5. So the two x values of our points here where they intersect, one of them is 4 and the other one is 5. And now we just need to find the y values. But to find the y values, you just go back up to this one here. So I'll just do one of them just to save time. So y is equal to 24 minus 5, but one of the x values is actually 4. So that's going to be y is equal to 24 minus 20, which is 4. So the other y value there, if x is equal to 4, we're actually getting there that y is equal to 4. And you would do the exact same for that one. So just to recap there very quickly, if you want to find where a line and a circle cut each other, it is just simultaneous equations that you should be familiar with from 5th year. Question here I want you to try on your own. So show that the line x plus y is equal to 5 and the circle x squared plus y squared is equal to 2 do not intersect. So what we're trying to show is that they maybe look something like this here. So there's the circle and there's the line, and we're trying to show that they do not intersect each other. Okay, so I want you to give this a good go, and I'll do it now in a second. Okay, so there are two ways of doing this. The first way of doing it is you could just solve simultaneous equations between our line and the circle. So just like in the first example I did. When you do that, you will obviously get a quadratic, but when you try to solve the quadratic, it won't work. You won't be able to solve the quadratic. Even if you try to use the minus b formula, you will get imaginary answers. So that means that that line and that circle do not intersect. But there is another way of doing it. And I just want you to show you the other way of doing it. So if we look here, this line here is the line x plus y is equal to 5. And this here is the circle x squared plus y squared is equal to 2. Now we should know now, because it's in that format, we should know that the center of that circle is 0, 0. And the radius of the circle is the square root of 2. Okay, so another way of doing this is, if I was able to find the distance between this point and this line, and if that distance there, I'll call it d, if that distance was bigger than the square root of 2, then it would mean that the line does not touch the circle. Okay, so just in case that doesn't make sense, I'll just repeat it again. So we're going to find this distance here between the center and our line. We're going to find that distance. And if that distance is bigger than root 2, which is the radius of the circle, it must mean that the situation is like this and the line does not touch the circle. Okay, so this has a nice bit of revision in it, because how do we find the distance between that point and that line? Well, that would be the perpendicular distance from a point to a line, which we did. Okay, so the formula is the perpendicular distance is ax1 plus by1 plus c all over the square root of a squared plus b squared. So I covered this in video 1. So let's fill this in. So my line is x plus y. I'm just going to bring over the 5, minus 5 is equal to 0. And my point is the point 0, 0. So again, to fill it in, remember, this line here is in the format ax plus by plus c is equal to 0. And this point here is obviously my x1, y1. So to fill it all in now, my distance is equal to, okay, so a is obviously 1, by x1 is 0, plus b is also 1, by y1 is 0, minus 5 is my c, all over the square root of a squared, which is 1 squared, plus another 1 squared. So my distance now is equal to, so that will go to 0, that will go to 0, the absolute value of minus 5 all over the square root of 2. And then we now know that the absolute value means that we just ignore the minus, so that's 5 all over the square root of 2. And then I just put that into the calculator. 5 over root 2 is 3.5. So that means that the distance between here and here is 3.5. But the radius is root 2. And root 2 as a decimal is only about 1.4. So if the radius is only about 1.4 and the distance between them is 3.5, then that also proves that this line and that circle don't touch each other.